So before reading this article and coming to college, my understanding of engineering was, like they mentioned in the article, that it was males doing science and math, and that was about it. When in reality, that's not exactly what engineering is. It is practitioners are people that help improve others' lives by using their creativity to solve real world problems. So it's still a lot of art and creativity and problem solving, whereas some people think it's just the math and the science. To bring the conversation of engineering into the classrooms is really important, and especially because right now we need more engineers who are from historically underrepresented groups, to try and get more diversity in the field and so that everyone is represented. Another thing that can be talked about and brought up in conversation is talking about the engineer's pledge, like it stated in the article, talking about how there is a creative aspect of engineering and there's a collaborative nature of engineering where you work with other people, and talk about how if you want to help people and make a difference in people's lives, engineering can also be a career choice for you. To help guide young people to these conversations, for example, a Norwegian company has created commercials based off young people pulling pranks or creating roller coasters with technology and using engineering as young people. Another thing that we can do to bring in engineering into the classroom is get college students to come in and talk about engineering if they're in the program and the different types of engineering, because there's not just one, there's so many different fields of engineering that these kids can get into. And another thing that could be fun is taking field trips to science and technology centers or scientific museums, and so these kids get the hands-on experience of seeing engineering in the real world and understanding that it is something that is not out of their reach and they can actually be a part of. The biggest thing that I liked that I think can be really easy to incorporate into a classroom was thanking an engineer. So it basically said pick a technology that you can't envision your life without, and the kids could even pick this or you could give them ideas, and basically an engineer created that. Someone was problem solving and wanted to help others, and so they created an iPad or a bike or an oven. And so seeing those things that we use in our everyday life an engineer created, I think could really inspire kids to be like, oh, hey, I want to do that too. And those were the main things that I thought were most important from that article and ways that I would like to bring engineering into my future classroom.
Hello, so today we are going to talk about the engineering design process. And what the engineering design process is a step-by-step process that engineers use to help solve problems. So it is actually a circle instead of going from start to finish. So even when they reach the end, engineers continue to go around the circle and the process is never ending. So the first step, or sometimes a place where they would start, is asking questions to identify what they need. The next step would be researching the problem, then imagining possible solutions, planning, creating a prototype, testing the prototype, and then improving the prototype, which would take you back to the beginning of asking and researching and planning. It's different from the scientific method because the scientific method is developing an experiment to answer a question, and it only tests the hypothesis, whereas the engineering design process is creating a solution to problems and the questions that you have asked. So some things that you could use the engineering design process for in the classroom specifically would be to have the students create or build something. So creating a boat with certain materials that they can get to float, or it can even be something like creating ways to upcycle trash. So using things that you would normally throw away in the classroom and having your students ask questions and then design ways that they can reuse that trash. The resource that I found that I really liked was tryengineering.org, and it had a lot of resources, not only just for teachers, but for teachers to then share with parents as well as students. They have games. There is a section where you can meet an engineer where it talks about real life engineers and what they do. There are lesson plans, and there are also e-learning resources. For COVID-19, I found that to be my favorite part, just because you can either use this resource for in-class things, or you can also use it if you're teaching remote during COVID.
The project that I decided to do was to invent a back scratcher from everyday materials. Both cost and prep time was low, so this can be something that you can do in any classroom at any time. The standards that this aligned to were the kindergarten through second grade ETS 1-1 and 1-2 standards, which is asking questions, making observations, gathering information about a problem, and then the second standard, developing a sketch or a diagram to present a solution to the problem. One way that you could easily adapt this project to different grade levels is changing the materials that you give your students based on their grade level and or ability to create. For my classroom project, I have designed a week of lessons to do during science to incorporate the engineering designing process. And so for our classroom project, we are going to do the benefits of inclined planes. So I have laid out kind of just a timeline of the week for lessons. So for this project, the engineering standard that it aligns to is the kindergarten through second ETS 1-2, which is developing a simple sketch, drawing, or model to illustrate the solution to a given problem, and 1-3, analyzing data from tests to reflect on the performance. For the next generation science standards, you could take this lesson one of two ways. For kindergarten, you could go PS2-1, which is the effects of different directions on an object, or you could adjust the lessons a bit to make it work for second grade and work with PS1-2, which is determine which materials have properties for an intended purpose. So instead of using the same material for all students, changing the different materials and having the students have to determine which one works best for their purpose. So just a quick outline of the weekly lessons. For day one, it would be your introduction into inclined planes and the whole project. You could talk about inclined planes, watch some videos, do some activities, even go outside and see if you can find inclined planes in the real world. For day two, you would start brainstorming, review inclined planes, and then introduce the problem that the students are going to have to find a solution to, which is find the lightest way to lift a heavy bag of rocks or any heavy thing that you would like to have the students lift on their inclined plane, and have a pre-activity worksheet for them to do with real life uses of inclined planes. For day three, the students would start designing their sketches after they've looked at multiple inclined planes. Day four would begin testing, so the students will create and test their inclined plane that they designed. They will have to take notes and use a scale to figure out how useful their inclined plane is. And then day five, they would finish up their testing and do some reflections on how well their sketch and their inclined plane actually helped to solve our problem of lifting a heavy bag of rocks. So that is just a brief outline of the inclined plane lesson that you can do for the engineering design process throughout the week, and there are multiple ways that you could adjust this lesson for your individual class or grade level, but this is just an outline that I created for something that I could use in my future classroom.